Test, test, test. Hi guys. Thank you for coming to the review session. So it's 6:10 now. So let's just jump right into it. So our tutor for today is Nessa Julia. Yay. So yeah, take it away, Nessa.
Okay, I'll just share screen lang muna. Kita naman ba yung screen? Or,
Yes.
okay, thank you. So hi guys, I'm Nessa. Um, this session, let's make it super chill lang. So if you have any questions or anything, you can just unmute or kahit chat lang. Or yeah. So to start off, I wrote a few of the formulas for the coverage of LE2 since I think hindi siya lahat covered in the Samplex. So, I put down a few tips then on how I like to interpret the different problems and sana it helps also. So, like for continuous random variables, so we have five different kinds of distributions. So it's a continuous uniform, normal, exponential, Erlang, and Weibull. So for continuous uniform, usually it's indicated naman na there's an equal probability between two values, so that's A and B. And then for normal, it's also indicated that something or like the problem follows a normal distribution. And then to get the Z value, so usually you get it lang from the Z table. Pero kung they just give you one of the Z tables, so either the negative or the positive Z table lang, you can get the counterpart, so the positive or negative, by using this formula. So the phi of Z plus the phi of negative Z is equal to 1. So even if you're given the negative Z table lang, you could always solve for yung positive na counterpart niya. And then for exponential and Erlang naman, it's similar to the discrete distributions. So your exponential is kind of like your geometric. So it's the time until an occurrence of interest happens, and it's memory-less. And the Erlang is similar to your negative binomial. So it's the rth occurrence naman. And then for your exponential, using these formulas, it's important to remember lang na your lambda is always discrete, and that the distribution of occurrences, it follows the Poisson distribution. So the lambda is the same for both the exponential and Poisson. So if you're given like mean of the probability distribution is equal to something, that will be equal to 1 over lambda. So when you calculate lambda, you have to get the reciprocal of the mean pa. And then I think to remember it helps din siguro if you think of lambda as a discrete distribution. So laging dapat discrete yung value ng lambda. So let's say 3 people per minute, that's discrete since the people are countable. So you know that's your lambda na instead of 1 over lambda. And then for Erlang, it's the same, but it's an rth occurrence naman. And then Weibull, it's always specified your shape and scale parameters. So you know kaagad it's Weibull because you have your beta and your delta. And then for the joint probability distributions, I think it's medyo straightforward naman in the question. So usually have to memorize the formulas lang talaga and then plug them in the plug what's given in the formulas. So I'm not sure if I wrote everything, so baka don't like fully rely on this. But yeah, I wrote some of the formulas here. And then another probability distribution pala, but it's discrete, is your multinomial RV. So it's an extension of the binomial RV. What's different lang between the binomial and the multinomial is the multinomial has at least 3 outcomes per trial. Since your binomial, it's always p or 1 minus p lang, kasi you only have 2 different possibilities. Your multinomial, there's at least 3 outcomes. And then you could plug in this formula lang to get the answer. And then for continuous joint distributions, same siya, na usually you plug in the values lang. So it's important to know how to get the function, the f of fxy, and then know how to get the bounds also. So usually what's important here lang is if this is in terms of y, dy has to go first, and then the outer one corresponds to this dx. And then last na, so for covariance and correlation, you just have these formulas. And then if it's independent, since your EX times EY is equal to EXY, it would always be 0 if your X and Y are independent. And then for linear combinations naman, this is the formula lang for the mean and variance if it's a linear combination. And then the sum of individual normal RVs is also normal. Okay, so I guess we can start now with the Samplex. It helps siguro if you have a copy of the Samplex open, since I'm not sure if kita lagi in the screen. Pero yeah. Okay, so for the first, the modified true or false. So the first one is Erlang RV gives the rth boson success within a time interval. So since it's Erlang, it's always rth boson success. Kasi if it's the first success lang, that's your exponential. So this is true. For the next naman, it says for any continuous random variable x, any probability that x is equal to any real number is greater than or equal to 0. So for this, I think it's in the PowerPoints then na the probability of x being any number would be equal to 1 over infinity. So that's equal to 0. Since sa continuous random variables, you're technically getting the area under the graph. So if it's a single number lang, the area under the graph would be 0. For the next naman says the CDF value always increases as x increases for any continuous random variable. So for this one naman, I think there's also a property that if x1 is less than or equal to x2, then f of x1 is less than or equal to f of x2. So it's not always increases kasi it's possible that it also stays the same even if x increases. And then for number 4, if x and y are independent, then the joint PDF of the two variables is given by the product of their marginal PDF. So since x and y are independent nga, you can get their marginal PDF by just multiplying the two, because that's a property that's given if two random variables are independent. So it's true. And then for the number 5, standard normal RV is a special case of normal RV with mean equals 1 and standard deviation equals 0. So this one, pinagbaliktad lang nila yung mean and standard deviation, since for standard normal RV, your mean is supposed to be the one that's equal to 0 and your standard deviation is equal to 1. For number 6 naman, for continuous random variables m and n, we integrate across m to get the marginal PDF of n. So this one is this formula. So f x of x is equal to y f x dy. So for this naman, if you want to get the marginal PDF of n, you have to integrate it across m. So it's like this. For the next naman, in a joint bivariate continuous probability distribution, the probability is given by the area under the graph. So since bivariate siya, you know that there's already two axes. So that's your x and y axis. So if you draw the graph, it becomes 3D kasi the third axis will be your value of z. So instead of area of the graph, it should be volume under the graph. So if it's only area of under the graph, if it's a univariate continuous probability distribution. And then for number 8 naman, it says if the LE2 scores of the students taking IE27 is normally distributed with a mean of 68 and a variance of 16, the corresponding z value for getting the probability of those who failed is given by z equals negative 0.5. So for this, the formula that you should use is z equals x minus mu over sigma. So since it's given here that we're finding for the probability of those who failed, your x will be equal to 60. The mean is given to be 68. And then since we're given the variance instead of the standard deviation, we should get the square root of the variance. So that's square root of 16. And this will be equal to negative 2. And then for number 9 naman, for Weibull RV, if the scale parameter is greater than 1, the occurrence rate increases. So, instead of the scale parameter, it should be the shape parameter. So that's your beta. And then number 10 naman, if the two variables are independent, their covariance will always be 0. So, usually if I encounter problems like this, I like to write the whole equation first. So, it says the covariance is equal to 0. So, that's your sigma xy equals exy minus e of x times e of y. So, since we know na e of x times e of y is equal to e of xy, if both x and y are independent, their covariance should then be equal to 0, since it just simplifies into this. So the number 10 is true. Okay, moving on naman sa actual problems. Just tell me na lang if I'm going too fast, or yeah, if you guys have any questions or clarifications. Okay, so for problem 1, it says Blacklist International will face Echo Philippines in a best of 7 series. So the first team to win 4 games will be crowned the champion in the grand finals of MPL PH Season 10. So Black's average time is exponentially distributed with a mean of 17 minutes, and each game is independent of each other. And then answer the following questions. So some of the problems, kasi usually pag IE27, they look super long and intimidating. So I like to start out by writing the given muna to just see what I know about the problem, and then try to find out which type of continuous distribution I should apply to get the answer to the problem. So the given here though is the mean is 17 minutes, and it's exponentially distributed. So since the mean of an exponentially distributed RV is 1 over lambda, so I can get lambda to be equal to 1 over 17. So if it didn't explicitly state na it's the mean, pero you know it's 17 minutes, and since that's not discrete, it's kind of a clue na rin na your lambda can't be 17 minutes, since lambda is always discrete na. So usually you get the reciprocal of that, so 1 over 17. And then it's asking here, what's the probability that the first game during the grand finals will end in less than 16 minutes? So plugging in the formula lang, it will become 1 minus e to the negative lambda times x. So that's 1 minus e to the negative 1 over 17 times 16, which is equal to 0.6098. Okay. And then for letter B, it says, assuming BLCK won the championship with a final score of 4-2, what is the probability that the total game time during the grand finals was more than 2 hours but less than 3 hours? So, for this naman, it says that they won the championship with a final score of 4-2. So that means that the whole game ended in 6 games. So, that means na the game ender was the 6th occurrence. Kasi by the time BLCK won their 4th game, the game ends na. Kasi they're crowned the champion na after 4 games. So, here naman, since lambda is in minutes, since it's 1 over 17 minutes, we have to convert the 2 hours and 3 hours into minutes para same yung units niya. So, the 2 hours would be 120 minutes, and the 3 hours would be 180 minutes. So, to get the probability, it will be px less than 180 minus the probability that x is less than 120. And since it's the 6th occurrence, it gives us a clue na rin na it's Erlang. Since exponential will give you the first occurrence, and Erlang will give you the 4th occurrence. So if we plug in the formula for Erlang, so that will be 1 minus summation of e raised to negative 180 over 17 times 180 over 17 raised to n over n factorial, where n is from 0 to 5, since r minus 1 is equal to 5. And then we subtract 1 minus the summation of e raised to negative 120 over 17 times 120 over 17 raised to n over n factorial, from n equals 0 to 5. So if you plug this in the calculator, it will become equal to 0.2454. Okay, and then for number 3 naman, it says what's the probability that in the 6 games played by BLCK and Echo in the grand finals, no more than 3 games lasted for more than 20 minutes but did not exceed 25 minutes. So, if you break down the problem, we can get the probability muna that the game lasted more than 20 minutes but did not exceed 25 minutes. So this would use exponential since it's one occurrence lang naman. And then for the no more than 3 games, since the games are discrete naman, we go back to the discrete distributions. So it's telling us na no more than 3 games lasted for more than 20 minutes but did not exceed 25 minutes. So in order to solve that, we have to use the binomial distribution. So solving for the probability muna, we can plug in lang again the exponential distribution na formula. So this is equal to probability of x is less than 25 minus probability that x is less than 20. So this is 1 minus e raised to the negative 25 over 17 minus 1 minus e raised to negative 20 over 17. So this is equal to 0.078574893. And then going back to the formula of binomial distribution, so to get the probability, we use n choose x times p raised to x times 1 minus p raised to n minus x. Since we want na no more than 3 games lasted for more than 20 minutes but did not exceed 25 minutes, we have to use the summation. So summation from x equals 0 to 3. And then your n would be 6 because there's 6 games in total. So it'll be 6 choose x times your p, which is 0.078574893 raised to x. And then 1 minus p naman raised to 6 minus x. So this formula means na these x games will last from 20 minutes to 25 minutes. And then the 6 minus x games naman, it doesn't matter how long they last. Basta it's not between 20 and 25 minutes. So if we plug this in the calculator, it will be equal to 0.99949777535. So that's about 0.9995. Okay. And then for the next problem naman, it says, based on the previous BLCK versus Echo matchups, the first one has a 2/3 chance of winning a game versus Echo. So what's the expected total game time of the grand finals of MPLPH Season 10, given that they win the championship? So again, since the games are discrete, so the probability of BLCK winning a game follows the binomial distribution. So it's a binomial random variable. So that they since they win the entire game, if they win 4 games, we know na the expectation should be equal to 4. So the formula for expectation of a binomial random variable is NP. So this is equal to n times 2/3. Since the probability given is 2/3, this should be equal to 4. So that means there should actually be 6 games. And then for the expected total game time naman, since we already have the number of games, we can use the Erlang random variable. So E of x is equal to R over 1 over lambda. So that's 6 over 1 over 17 or 102 minutes. So we first get the expected number of games for them to win muna. And then once we get that, we can solve for the total game time after. Okay. Now moving on with problem 2. So the problem 2 naman, you're given a table lang with the probabilities given if you have or don't have headaches, cough and colds, and seasonal allergies. So for the first question, it says, what's the probability that the patient seen does not experience any headache? So the probability that the patient doesn't experience headache, we can just look at this column. So all the no's, we add all the probabilities. So it's 0.486 plus 0.144 plus 0.092 plus 0.076. So that is the first four outcomes. And that would be equal to 0.798. For the second question naman, it says, what's the probability that the patient has no headache but has cough and colds? So for this, we can just look at the table again. So the probability na no headaches daw but has cough and colds. So no headaches and has cough and colds, it's this two outcomes. So that's outcome 3 and 4. And then we just add their probabilities together. So that would be equal to 0.168. And then for the third problem, it says, what's the probability that the patient has a headache or appears to have seasonal allergies? So since it says or, we get the union of the two. So based on the table again, we can see that this corresponds to outcome 2, 4, 5, 6, 7, and 8. So since it says or, it doesn't matter if both of them are satisfied. Basta at least one is satisfied. So either they have a headache or they have seasonal allergies. So it's 2, 4, 5, 6, 7, and 8. So the total probability would be equal to 0.422. And then for the next problem, it says, what is the estimated number of patients seen with cough and colds if the total number of patients seen in the triage that week is 1,000? So for expectation, we get 1,000 times the probability that the patient has cough and colds. So based on the table again, these would be outcomes 3, 4, 7, and 8. So if we plug this in the calculator, this would be equal to 288. And then for letter E naman, it says, what is the probability that the patient seen has a headache given that he or she has cough and colds? So with the word given, we know that it's the conditional probability. So based on the formula of conditional probability, we can get that P headache given cough and colds would be equal to probability of headache intersection with cough and colds over the probability of cough and colds. So going back to the table again earlier, outcomes 7 and 8 are the ones where headache and cough and colds are both present. So that's your numerator. So 0.012 plus 0.108. So that's outcome 7 and 8. And then for cough and colds naman, you just add all the probabilities where there are cough and colds. So that's 0.092 plus 0.076 plus 0.012 plus 0.108. So that's outcomes 3, 4, 7, and 8. So this is equal to 0.4167. And then for letter F naman, what's the expected value of patients seen not having a headache, given that it has been recorded to have cough and colds? So since we see the word expected value, we would do conditional mean, since there's a condition here na it has been recorded that the patient has cough and colds. Since we're finding the expected value of not having a headache, we can let x of h be equal to 1 if no headache, and x of h equals 0 if with a headache. So the expected value of no headache would be equal to 1 multiplied by 0.092 plus 1 multiplied by 0.076. Since this is the no headache, its outcomes 3 and 4. No headache, but there's cough and colds. And then over the total probability of cough and colds being present, so that's 0.092 plus 0.076 plus 0.012 plus 0.108. So that would be equal to 0.5833. And then for letter G naman, what is the probability that the patient seen does not have headache nor seasonal allergies, given that he or she has cough and colds? So no headache, no allergies, and cough and colds. That corresponds to outcome 3 in the table, so it's 0.092. And then from earlier, we solved that the probability of cough and colds is equal to this, which is equivalent to 0.288. So this is equal to 0.31944. Okay. Now moving on to problem 3. So it says here, Ralph took on a sales job and earns commissions as part of his income. On the average, he gets about 2,300 pesos commission for every closed sale, with a standard deviation of about 285 pesos. In the past 6 months, Ralph was able to close 57 sales transactions, assuming that the income from commissions as well as the other streams of income follow the normal distribution. And then determine the following. So the first is, what is the probability that Ralph earned at least 135,000 after closing 57 transactions in the past 6 months? So what we're given is the mean is 2,300 per sale, and then standard deviation naman daw is 285. So since our mean is defined per sale, so that we can use the formula na z is equal to x minus mu over sigma, we have to turn x into per sale also. So x daw is equal to 135,000 that's for closing 57 transactions. So we get 135,000 divided by 57, which is equal to 2,368.421053. So probability of at least 135,000 for 57 transactions would be probability that x is greater than 2,368.42105. Greater than or equal to. So that's equal to 1 minus probability that x is less than 2,368.42105. And then since it's given that it's normally distributed, we can use the formula z equals x minus mu over sigma. So that's equal to 2,368.42105 minus 2,300 over 285. So that's equal to 0.2400738,689. So since the z table usually shows 2 decimal places, we can round it off into 0.24. And then based on the z table, so this is 0.2, and then this is the column for 0.04, we can get na phi of 0.24 is equal to about 0.5948. So this would be equal to 1 minus phi of 0.24, which is equal to 1 minus 0.5948. So that's equal to 0.4052. For the next naman, it says, on better days, Ralph can earn a windfall on just one sale. So considering around 1% of the biggest transactions that he was able to close, what is the minimum commission that he will be able to bring home on a single transaction? So since it says 1% of the biggest transactions, this would be the upper 1% of the graph. So parang the graph looks like this for Z table. We're looking at this upper 1%. So that's Z 0.99. So we have to find in the Z table what is closest to 0.99. So that would be equal to 2.33. So since this is, I think, 0.00, 0.01, 0.02, 0.03. So this would be equal to this, the closest to 0.99. So that's equal to 2.33. So plugging in the formula lang, 2.33 is equal to x minus 2,300 over 285. And then multiplying 285 to 2.33, we get 664.05 equals x minus 2,300. So x would be equal to 2,964.05. And then for letter C, it says here na on a monthly basis, Ralph summarizes his income streams as follows. So the first is he closes 9 sales transactions every month with an average commission of 2,300 pesos and deviation of 285 pesos daw. And then The second income stream is his fixed part-time work, which is 60 hours, and an average hourly rate is 75 pesos, and standard deviation is 5 pesos. And then the third naman is he has a loss of about 583 pesos a month for storage costs, with a standard deviation of 68 pesos. So it's asking here na Ralph is planning to buy a new house and wants to make an assessment of his finances. He already has money saved up for the down payment, but is worried about the monthly amortization. And the estimated monthly mortgage is 25,000 pesos. So what's the probability that Ralph can actually afford the monthly mortgage, considering the gains and losses from the identified three streams of income? Since we know that Ralph has three different streams of income and they each have their own average and standard deviation, this is an example of a linear combination. So we can let C to be the commission per sale, P the wage from his part-time work per hour, and S the storage fees. And then I would be the total income. So following the formula lang for linear combination, we can get I is equal to 9 times C, since there's 9 sales transactions. And then since there's 60 hours of his part-time work, we can add 60 S, and then 60 times P. And then since the storage fees is a deduction from his income, we can add -1 times S. And then using the formula for linear combination, this would be 9 times, we know na the average is 2,300 pesos. 9 times 2,300 plus 60 times, the average daw is 75 pesos. So times 75 plus -1 times 583. So that would be equal to 24,617. And then we also have to solve for the variance, since we know na the normal distribution, the formula is z equals x minus mu over sigma. We have to solve for mu and sigma. So we already solved for mu. Now we're solving for sigma using the formula for variance of a linear combination. This would be 9 squared times the variance squared. Times the variance. So, and since we're given the deviation, standard deviation, we have to square the value pa to get the variance. So it says the deviation daw is 285 pesos. So it would be equal to 285 squared, and plus 60 squared times the deviation daw is 5 pesos. So to get variance, we have to square it also, times 5 squared plus -1 squared times the standard deviation of 68 pesos. So times 68 squared. So this is equal to 6664601. And then since this is the variance, the standard deviation, we get the square root. So square root of 6664601. And then we want to know if Ralph can afford the monthly mortgage. So that means the probability that X is greater than or equal to 25,000. So we can get this by 1 minus probability that X is less than 25,000. And then since this follows, since each of them follow a normal distribution, and there's a theorem that the sum will also follow a normal distribution, we can get Z equals 25,000 minus the mu we got earlier, so 24,617 over sigma I. So that's square root of 6664601. So that is equal to 0.15. So this is equal to 1 minus phi of 0.15. And then based on the Z table again, we can find 0.15 here. So it's 1 minus 0.5596, which is equal to 0.4404. Yeah. I think that's the end of the samplex, but I also included one more problem, since I think a prof said na it's important to know how to graph for continuous PDFs. So for this problem, it says Bill and Tanya are each given a 250 milliliter glass. If they put soda in each of their glasses such that the amount each of them has can be described as uniformly distributed between 100 and 225 ml, find the probability that the total volume of soda in the glasses is at least 300 ml. So what we're looking for is the probability that total amount of soda is greater than or equal to 300 ml. So if we let x be equal to the amount of soda in Bill's glass, and y naman is equal to the amount of soda in Tanya's glass, we can rewrite it into p, probability that x plus y is greater than or equal to 300. And then since this is a joint probability distribution, we need to solve for f of x, y. And then we know na the amount of soda that they put in their glasses are independent of each other naman. This would just be equal to f of x times f of y. And then we can also solve for your f of x and f of y. Sorry. Since we know na they are uniformly distributed though. So this would be equal to 1 over b minus a. That's the formula for the continuous uniform distribution. So that's 1 over 225 minus 100. So that's 1 over 125, which is also equal to the one for y, since they're both uniformly distributed naman between 100 and 225. So we can get na xy would just be equal to 1 over 125 times 1 over 125. So that's 1 over 15,625. Where x and y daw are from 100 to 225. So if we want to solve for the probability, we would have to integrate it. So that'll be equal to bounds of x and bounds of y, and then 15,625 dy dx. And then it's hard to find the bounds if you just look at the problem like this. So it helps if you draw the problem. So if you draw it, it would look like this. So since the lower bound of x is 100 and the upper bound is 225, because it's uniformly distributed between 100 and 225 daw, we can draw a square. So that's 100, 225, and 100 and 225. And then we want the probability that x plus y is greater than or equal to 300. So we can graph x plus y equals 300, and then the probability that we want is this upper half. And then from here, since this doesn't look like a triangle, it would be hard to get the probability of this one. So instead, you can also do 1 minus the lower half naman. So since it's a triangle lang, it would be easier to get its bounds. So probability that x plus y is greater than or equal to 300 is equal to 1 minus probability that x plus y is less than 300. So for this, you can draw vertical na rectangles. So it's like math 21 or 22. You just get the bounds of x and y. So this would be equal to 1 minus finding the bounds pa. So dy dx. So if we put dy muna here, this should correspond with the bounds of y. So wait. We can start with dx na lang muna, since it's the outer bounds. So the outer bounds shouldn't contain any function in terms of y, or else hindi siya masasolve at the end. So your dx would be equal to 100 to 200. Since we know na the lower limit would be 100. And then since the lower limit of y is also 100, this would be 100 plus x equals 300. The upper limit is 200. So this would be 100 and 200. And then for y naman, since we drew vertical rectangles, we know na the upper limit is this line here, and then the lower limit is just y equals 0. So since we know that the line we drew here is x plus y equals 300, we want to write it in terms of x since your x is the outer bound nga. So y is equal to 300 minus x. So this one's 300 minus x, and then the lower bound is 0. And then if you plug this in your calculators, you should be able to get na the probability would be equal to, I think 1 minus 0.32. So it's equal to 0.68. Yeah, that's it. I think we did the whole samplex na rin. Is it too early ba? Jerome, you.
Di naman. If you're done, then you can finish. Just if you
Yeah.
have any last words. Any last words?
Um, last words talaga. Yeah, feel free to chat me lang if ever you have any questions. Kahit after this, if you're reviewing and then you find the question that you're unsure of, I'll try to help as much as possible. And then I think just advice lang for IE27 is usually the problems look very intimidating talaga. But it helps if you can break it down and then just write the given so that you can parang relate it to other problems you've done in the past and see what formulas or distributions you can apply to it. So yeah, that's it naman for me. I hope you guys learned something kahit konti.
Okay. Yep. Thank you everyone for coming. So again, if you have any questions, just message me. Ay, you has a question though in the chat.
Ay,
Do you have other non-content related exam tips for 27?
um, what do you mean by that?
Feel ka mental, ganun.
Um, I think 27 talaga, your biggest kalaban lang talaga is yourself. Like, I think it's super intimidating kasi usually mga IE27 problems. Even when we had it last year, parang a lot of people got intimidated pa lang when they saw like really long problems. But yeah, I think it would help talaga if you would break it down and make sure na parang you understand how, I think sometimes how the formulas are derived then. So parang you get the um parang you understand all the concepts talaga fully kasi sometimes they like to like iniiba-iba nila yung questions, so it's not as straightforward as putting in the formula sometimes. Pero yeah, kaya niyan.
Diana also asked, is it common to have problems that involve both discrete and continuous distributions?
um hmm I think medyo nakalimutan ko na on our time, like when we took it. Pero I think it helps to at least know how to do yung binomial distribution since usually yun yung sinasama with other continuous distributions. Like yung game problem kanina. After you solve for the continuous distribution, you have to incorporate the binomial also since the number of games are discrete nga. Pero yeah, I think usually binomial lang talaga kailangan.
Um, Also, before we end this review session, please answer the feedback form. I'll send it through the chat and also sa batch group chats and sa batch reps I will send. Make sure to please answer kasi we need your student numbers for the involvement task for today. Thank you so much.
Thank you all for coming, and thank you very much, Tanessa.
Thank you guys.
Pwede na kayo umalis. Bye. Amen. Bye, guys. Bye, bye. This is goodbye.
Yes, bye-bye.
When I see you... Oh my God, nagsistream ka pa ba?
Nagsuscript tayo.
Hello, stream watchers. Bye, guys.